Good morning. Today we're going to talk about geometry, and we're going to review the concepts that we've already learned. So geometry is the study of shapes, two-dimensional and three-dimensional shapes. Two-dimensional shapes are flat, and three-dimensional shapes are like boxes, or they're real shapes. So today's essential question is, what is the difference between volume and surface area? So they're two very distinct things, but they have to do with the same shape. So hopefully by the end of this lesson and these notes, you'll know what the difference is and how to find and solve problems that involve volume and surface area. So first, let's start with a review with the term perimeter. Now, perimeter means the distance around a shape. And to find it, you add all the side lengths. All right, so let's do an example. So if I have a rectangle, and my rectangle has a side length of 3 centimeters and a side length of 2 centimeters, I'm going to find the distance all around the rectangle. And to do that, I'm going to add all the sides. So I have 3 and a 3, or I'm sorry, a 3 and a 2. Now, this side is equivalent to this side. They're the same length. So I'm going to have another 3. And this side is the same as this side, so I'm going to have another 2. So 3 plus 2 is 5, plus 3 is 8, plus 2 is 10. 10 centimeters. Now you can also do this by taking your two sides, your length and your width, 3 plus 2, and understanding that it's going to be 2 times that because those are the same on the side. So take this and multiply by 2, and you can also get the answer. Another term that we need to remember is area. And area is the space inside the shape. All right, well, with area, we have some important formulas that we need to use. So for a rectangle, we would do length times width. For a square, we would have side times side, or we could also do side squared because it means the same thing. Make that a little bit bigger so maybe you guys can see it better. Okay, too big. Reining it in this angle. Okay, then another one that's really important for us to remember is a triangle, which a triangle is really just half of a rectangle or half of a square. So for a rectangle, we would do length times width, right? But for a triangle, we don't do length times width, we do base times height, which, by the way, is kind of like the length and the width. And because it's half of a rectangle, you divide it by 2. All right, so let's put this into practice. Let's create a shape. So if I have a shape that has maybe a triangle over here, a long rectangle part, and then maybe like a square over here. Actually, that's not a square. Well, we'll do a rectangle there. Okay. If I did that and I said, okay, this distance up here is 10. Sorry, that's a balloon that just popped in my room. And this space over here is, well, this is 4 here. That's this space. And then this space is going to be 10. And this space here is going to be 4. And this space all the way around to 6. And we're going to create there. So what I like to do is I take this shape and I'm going to break it down into smaller shapes. So I'm going to say I have a rectangle. Now I know that doesn't look like a square because Miss Engel drew it a little bit messed up. But let's say this is a square, a rectangle, and a triangle. Okay, so I need to find my lengths. Well, there's a couple tricks that we can do here, okay? So the tricks that we can do is, actually this isn't right. Let's say this is 2. All right, so a couple things that we need to know. We have a square here. Well, a square is side times side, right? So it would be 4 times 4, which is 16. So that would be for this one. This would be 16. Now this rectangle in here that we have is going to not be 10 because that's the whole length from here to here. I only need this length right here, which is 10 minus the 4 that we used already for our box. Well, 10 minus 4, my area in here is 6. And then I'm only going from here to here, which is 10. So I'm going to say this is 10 times 10. I'm sorry, 6 times 10. So my rectangle is 6 times 10, which is 60. So 6 times 10, which is just that part. And now I have a triangle. So my triangle, I have a 2 here. Well, I need to know my height. Well, look. Here's 6. So that would be 6. So I have 2 times 6 divided by 2. Well, 2 times 6 is 12. Divided by 2 equals 6. So this one is 60. This one is 6. All right, so now we start adding it up. I add the 6 and the 60 and the 16. And I'm going to get 60 plus 16 is 76, plus another 6 is 82. And we're going to have, because I don't know the units, units squared. Always, this is important, square your units on area. Okay, so that is, by the way, what we would do with a composite figure. So this is a composite figure, which means it is composed of multiple different shapes. So to find the area of a composite figure, you break out down the bigger shape into multiple little shapes and do the formulas that you already know for those little shapes. So I did the formula for a triangle, base times height divided by 2. I did the formula for square, side times side, and I did the formula for a rectangle. Okay, I'm going to turn the page now. You can pause at any point if you need to. And we're going to do now, excuse me, surface area. Okay, surface area is the combined area of all the flat surfaces of a shape or of a three-dimensional sorry, I spelled it wrong. Dimensional. When you're writing and reading at the same time. So it's it's the combined area of all the flat surfaces of a three-dimensional shape. Okay. So let's draw a three-dimensional shape. Here's a three-dimensional shape. We draw a box, draw some lines, connect my lines, and there's my three-dimensional box. Okay. With the three-dimensional box, you have a side here, like this would be side 1, and then on this side, you'd have side 2. Here you have the front, And back here you would have the back. Here's the top. And down here you would have the bottom. Okay? Three-dimensional shape. Now let's give some values to our three-dimensional shape. So let's say that this distance from here to here is 4 centimeters. And the distance from here to here is 6 centimeters. And this distance from here to here is 5 centimeters. All right, so our steps that we're going to do is we're going to find the area of each surface. And then add all together. All right, so I like to break it down by doing first, here is my top and bottom. So remember, the top and the bottom are equivalent, they're the same. So if you find one, you just need to multiply it by 2, and then you have the combined value of both. So the top, we need to find what is this length here? Well, it's the same as this one, 5. And then what is this length? Well, it's the same as this one. They're equivalent, so 6. We multiply those together, and you get 30, but that's just the top. We also need to do the bottom. So we multiply that times 2, and you get 60. That's the top and the bottom. All right, now let's do the front and back. All right, well, here's the front and the back we can't see. So we need to do the length times the width. So the length here would be 5. And your width, or your height there, was 4. 5 times 4 is 20, but we have a front and a back, so we need to multiply by 2. So you get 40. Almost done. We still have 2 sides. So we're going to do side 1 and 2. All right, so here's our sides. We have a length of 6. And we need to know the height. Well, the height is the same as this, which is the same as this, which is 4. 6 times 4 is 24. And we have 2 sides, so we need to multiply by 2. You get 24 times 2, which is 48. So the last step is let's add all of our shapes together, or our sides together. So 60 plus 40 plus 48. Well, 60 plus 40 is 100, plus 48 is 148, and we have centimeters, and we're still only doing the surfaces, the flat sides, so it's still squared like we did with area. And there's your answer. Okay. Now, we're going to finally finish this off with volume. So volume, and this is volume of a right rectangular prism, which is basically a box with right angles. And this is the area filling inside the shape. So it's all the space inside. To find this, you're going to do length times width, just like we did before, but we're going to add now height. So length times width times height. This is your formula. So to answer your question, the difference between surface area and volume is surface area is outside the shape. It's like the skin, and volume is what's inside. It's like the guts. So let's do one. Let's make a box. Okay, made my box. Let's have 5 centimeters as this length, 6 centimeters is this length, and 4 centimeters is this length, just like our last box. But this time we're going to use the formula to find the volume. So we're going to do our length, 6, times our height, our width, 5, times our height, 4. All right, let's multiply. 6 times 5 is 30, times 4. 30 times 4 is 120. Now, we have 120 centimeters. Now, here's something interesting. When we did area, we were doing 2 values that we were multiplying together, 2 dimensions, the length and the width. But with volume, we're doing 3 dimensions, the length times the width times the height. So, we don't square our answer, we always cube our answer, which makes sense when you're thinking about you're dealing with cubes. So what does that look like? Like that. You just put a little 3. Oh, you can't really see it. That is a 3 to the 3rd power. And that is volume, surface area, area, and perimeter. And that's geometry in a nutshell. Have a great day, you guys. See you soon.